Hi, Intermediate. We're back. Let's now look at when the index is not a square root. So, like, let's look at cube roots, fourth roots, fifth roots. So when the roots are higher, remember, if it's a cube root, you need like triplets. If it's a fourth root, you need, 4 of each. If it's a fifth root, you need 5 of each. Whereas if it's a square root, you need 2 of each, right? So it's sort of a different rule, but similar concept. Okay, so when I look at this, I can't have a radical in the denominator, and it's not a perfect, 5 is not a perfect cube, so I can't actually take the cube root of this. So what I'm going to do is I'm going to force it out. I'm going to force it out by making it a perfect cube. So I have to figure out, well, how many 5s do I need to be a perfect cube? Well, I already have 1, so that must mean that I need 2 more, because I need a total of 3 5s. What makes a number a perfect cube for a big 5, for a coefficient, not an exponent, for a coefficient, is that you have 3 of something. That's what makes it a perfect cube. So I'm going to give it 2 more 5s, so now it's 3 5s, which is going to make it a perfect cube. Because 5 times 5 times 5 is 125, which is a perfect cube. So this is going to simplify out to be a 5. And it's really important that you remember to put the index in the window, because if you don't, what I've seen students do, if they forget to put the index in the window here, they'll then take the square root of 25, right? Because 25 is a perfect square. But 25 is not a perfect cube. Okay, so we have to be clear on what's a perfect square, what's a perfect cube, what's a perfect fourth, and so on. So 25 is not a perfect cube, so it's going to stay under the radical. Okay, let's try another one. So this, we can't have a radical in the denominator. We have to force this out. This is a cube root, so it means in terms of coefficients that I need 3 of something, that I need triplets. So far I just have 1, 3. So I'm going to need how many more? How many more do I need to make that a perfect cube? Good, I'm going to need 2 more. So I'm going to multiply that by 2 more big 3s. And that's going to make that a perfect cube in the denominator. So the cube root of 27 comes out as a 3. And 9 is not a perfect cube. It's a perfect square. So again, remember to keep the little 3 in the window. If you forget the little 3 and you think this is a square root, you might simplify it, right? And it shouldn't be simplified. That's actually done right there. So 9 is not a perfect cube. Okay, I think we have some more here. Okay, now fourth root means you need 4 of something. So the worst thing to do here, not that it's technically wrong, it's just not a good idea, is you don't want to think like, oh, well, I need 4 25s. Right? You actually want to figure out what 25 is made of, right? 25 is made of 2 5s. It's what we would call a composite number. Composite numbers are made up of other numbers, unlike prime numbers, which are not made up of other numbers. Okay, so 25, I want to actually, instead of thinking of it as 25, I want to think of it as 2 5s. And if I have a fourth root, how many 5s do I need to make it a perfect fourth? So hopefully you said that you need 4 5s, right? Because a perfect fourth has 4 of something, 4 identical numbers. And so you can multiply this out to see what this is, or you could just know that if you have 4 5s under, you can pull 1 out, right? Because there's 4 under, so 1 out. And then this is 25, you got to multiply it by 2, so 25 times 2, 50. So fourth root of 50. And again, there's no perfect fourth in 50. So that's just going to be the final answer. Okay, so let's do the same concept here, but with variables now, and then we'll mix them both together. So right now, you're trying to get rid of the cube root in the denominator. Cube root means you need 3 of something. So how many x's do we have so far? Okay, we have 2 x's so far, right? So how many do we need? You need 3 x's, right? So how many more do we need, right? We just need 1 more so that we have 3 x's in the bottom. So once you have 3 x's in the bottom, you can take 1 out. And you get that. Okay, let's see what else we got here. Okay, we got a 5th root. How many h's do you need to simplify a 5th root, right? You can't have that radical in the denominator. So 5th root means you need 5. To be a perfect 5th, you need 5 of something. Right, so right now we have 2 h's. So how many more are we going to need here? We're going to need 3 more, right? 3 more because we have to make it a 5. We need 5 of something. So now I can simplify it because it's a perfect 5th. So the h is going to come out. And I can't do anything with this because 2 is not a perfect 5th. So it's going to stay under. So the final answer is going to look like that. It's the 5th root of h squared times 8 over h. Now sometimes you might have both coefficients and variables, and you got to fix both of them. So this is a 4th root, so we need 4 of everything. So right now we only have 1 3, but we need 4 3s. So we're short by 3 3s. So you can write it as 3 3s, or if you prefer, write it as 27. It's just up to you. Now we need 4 x's. Right now we have 2 x's. So how many more do we need? We're going to need 2 more, right? So we need 2 more so that we have a total of 4 x's. So whatever you give to the denominator, make sure you give it to the numerator. All right, so now the denominator is a perfect 4th. So you have 81x to the 4th, which is perfect. And let's see what we got in the numerator. So these are both under, so you have to multiply them. 3 3s is 27, and then 27 times 2, what are we going to get there? 14, 54. So we're going to get 54x squared in the numerator. And so now the 81 comes out as a 9. Sorry, the 81 comes out as a 3. And the x to the 4th comes out as an x. You'll notice you'll do that too. Every now and then you'll take a square root when you're trying to take a 4th root. You'll get used to it. And then this all stays under. So this is 54x to the 4th. Okay, and make sure you put the little 4 in the window. All right, let me see if I have any more for this particular video. Nope, that's it for this one. Okay, gang, we got another video coming up for this section, but then that should be it. 4 videos for this one. Okay, catch you soon. Bye.